In this video, we're going to be looking at the second method that we can use when solving quadratics. That method is going to be the method using square roots. So every positive number has two different square roots. It has a positive root and a negative root. So one example would be if we're trying to think of the square roots of 16, remember square roots are just what number when times itself, or when what number squared would be that number. So 4 squared we know is 16. However, negative 4 squared, negative 4 times negative 4 is also 16. So 4 and negative 4 are both square roots of 16. Now, generally, when we think of the square root of a number, we generally think of the positive square root, and that number is called the principal root, but it's not the only root. So we can solve an equation in the form of x squared equals a by taking the square roots of each side. So if we had something like 6 squared equals 36 and negative 6 squared equals 36, those are both true statements, right? So that tells us that 6 and negative 6 are both solutions to this equation, x squared equals 36. If I were to plug 6 or negative 6 into this, both of these would be a true statement. So one thing that we can do when we're trying to find our answers is we can write our answer like this using this notation, and we read that as plus or minus 6 or positive or negative 6. So in this situation, we could say x equals plus or minus 6, and that would be the solutions to this. So let's go ahead and take a look at how we can use square roots when solving quadratic equations. Okay, so let's look at this first example here. So it says, solve each quadratic equation by using square roots. If the equation has no solution, write no solution. We'll talk about that in just a minute. So we have x squared equals 49. So in order to solve this, what we have to do is think to ourselves, what number times itself is 49? So we have a pretty good sense that we know when x is positive 7, right? 7 squared is 49. But we have to remember that there's also that negative root in there. So anytime you use a square root, right, we're going to take the square root of both sides to solve this. Anytime you introduce a square root as an operation into your equation, we have to do plus or minus, the positive or negative square root. So this would be x equals the positive or negative 7. 121 is another perfect square. So you need to really make sure you know your perfect squares, because you're going to be seeing a lot of those here in this chapter. So x squared equals 121. So in order to solve this, again, we take the square root of both sides, remembering that we have to take the positive and negative square root of the right side. So the square root of x squared is just x. The square root of 121 is 11, and we get positive and negative 11. Okay. So for this one, x squared equals negative 4. Again, we can do the same thing. Take the positive and negative square root. So we get that x equals. And what number when multiplied by itself is negative 4? Well, it's not 2, right? Because 2 times 2 is positive 4. 2 squared is 4. It's not negative 2. Negative 2 squared is 4, right? Negative 2 times negative 2 is 4. So what number would this be? Well, in this course, in Algebra 1, this has no solution. Now, really, a more precise way to say this would be that it has no real solution. You'll learn about the types of solutions that this has in Algebra 2, but anytime you try to take the square root of a negative number, we would say that it has no solution. So square root of negatives do not give us real solutions. And so in our course, we're going to say that this is no solution. So let's go ahead and, with that same thing in mind, try and solve these equations. So before, our equations were just in the form of like x squared equals our number, but now we have a little bit more that we're going to have to do, a little more work. So we have x squared minus 9 equals 0. Now, we've seen this before. This is a difference of squares. Now, if you recall, when factoring, it always ended up factoring into a conjugate. and the conjugate turned out to be the square root of our first term and then the square root of our second term in this. So we had x plus 3 and x minus 3, and this would be equal to 0. So we'll come back to that. But if I wanted to solve this, because it's telling us to use square roots, so if I wanted to solve this using square roots, I would have to first add 9. So that's going to give me x squared equals 9. Take the square root of both sides, remembering it's the plus or minus square root. Square root of x squared is x. Square root of 9 is 3, and I get x is plus or minus 3. So again, if we go back to that factored form, it was x plus 3, x minus 3 equals 0, right? Because this is factorable. If I set each of these pieces equal to 0, x plus 3 equals 0, and x minus 3 equals 0, I would get precisely what I got through taking the square roots. So both of these methods are equally acceptable when they don't ask us to solve using square roots. So for these problems, I do want you to use square roots because that's what it's asking us to use. So we have y squared plus 16 equals 16. So again, let's get it in the form where it was like x squared equals a. So we're going to get this by itself. So we're going to subtract 16. And we get those cancel, y squared. 16 minus 16 is 0. So we have y squared equals 0. So again, we can take the square root. Square root of y squared is y. I can't actually take the plus or minus square root because 0 is not positive or negative, but its square root is 0. So this one actually just has one solution like this. Okay. So for this one, again, we want to get the x squared by itself because we're trying to find x. So I'm going to add 3. So that's going to give me x squared equals 64. Again, that's another perfect square, so that's nice. Take the square root, and we want it to be plus or minus. So that's going to be 8, and we get x here. Now, one thing that you notice, and probably notice, is all of these so far, except for this one, have had two solutions, a positive 3, a negative 3, a positive 8, and a negative 8. Now, as you saw in factoring, they're not always the same. The two solutions are going to be like opposites of each other in these situations. But what these solutions represent are the points on the curve where our graph of our quadratic actually hits the x-axis. And we talked about that briefly in the intro video. So if you take a look, our graph might look something like this. So this point here and this point here, those are the x-intercepts, which represent the solutions to a quadratic. So what happens when we have something like this? So we want to solve for z, so let's subtract 10. Subtract 10. We're going to get z squared equals negative 9. Take the square root, so we get that z equals what, plus or minus. Now remember, we're taking the square root of a negative. So if we're taking the square root of a negative, this actually means we have no solution. So what this really means, if we think about it in terms of a graph, right? If we think about it in terms of a graph, it means our graph does something like this, where it never actually hits the x-axis. So this is no solution. Okay, so let's take a look at one more set of these. So we have, we want to solve these equations by using square roots. Again, no solution. Make sure you write no solution. Now, in order for us to use square roots, we have to first isolate our variable. So in this one, t is being multiplied by 18. So we can divide by 18. Divide by 18. And I'm going to get that t squared equals 2 divided by 18. That fraction can be reduced to 1/9. So now I can take the square root of both sides, plus or minus. Now, if you remember, when we take the square root of something like a divided by b, square root of a fraction, it turns into a fraction of 2 square roots. So you basically just take the square root of the numerator, take the square root of the denominator. So that means that t then would be plus or minus. Square root of 1 is 1. Square root of 9 is 3. So we're going to get plus or minus 1/3. Okay. So for this one, subtract 25. Subtract 25. So we have 4x squared equals negative 25. Divide by 4. This fraction can't reduce, but I have x squared equals negative 25 over 4. They are both perfect squares though, so when I take the square root, I actually can't. I can't, right? Because of this negative, right? Because that negative's in there, this tells me it's no solution. So a negative in the radical means it's no solution. Even though 25 and 4 are perfect squares, this is still no solution because this number here is negative. Okay, a couple more, and then we'll finish this up. So in this one, we want to solve. So again, we want to get b by itself. So I'm going to subtract 40. So I have negative b squared equals negative 40. Divide by negative 1, right? Because we want it to be a positive b squared. So we have that b squared equals positive 40. Take the square root, plus or minus, right? I should be getting plus or minus. So we get b equals plus or minus. Now 40. 40 is not a perfect square. So I do want to simplify this. So I have to look at the breakdown here. So 40 is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. Now we're doing square root, so it's an index of 2, which means we're looking for pairs. So we have a pair here. So from each pair, we get one out. Since these were not paired, they stay in the radical as a product. So it would be b equals plus or minus 2 times the square root of 10. Okay? All right, last one. 4r squared equals 81. Divide by 4 to get r squared by itself. So we have r squared equals 81 divided by 4. That can't reduce, so it's going to stay that way. Take the square root, plus or minus. Lucky for us, those are both perfect squares, so we get that r equals plus or minus. Square root of 81 is 9. Square root of 4 is 2. So this would be our solution for this one.